Yeah, hi. So I'm going to be talking on the self-improving agentic architecture. So I have a pretty brief agenda in terms of I'm going to be starting off with what self-improving agents are about, and then I'll talk a little bit more in terms of what the industry is currently doing in this segment, and then eventually we will get to a point looking at what is in store for the future. So when we coming out with the self-improving agent, I think first let's kind of get the basic definition right in terms of what exactly are we talking about self-improving agents. Now we've been building, a lot of agentic AI code in the past, year or so, and we've seen a lot of frameworks, everything from the Microsoft AutoGen, LangChain, and all of these are actually coming around, giving a lot of the framework features for agentic AI. Now, when we're dealing with agentic AI, we're not just talking with a single agent. Now, there are chances, there are very, from an architecture standpoint, you are likely to see approximately, minimum of 8 to 10 agents in a very simplistic scenario, kind of working together to kind of get the task done. Now, in situations where you actually have agents collaborating with other agents and, trying to get the overall task or workflow, which is they're set out to do, then it's important to already understand that there are chances that the agents are likely to go wrong. And effectively, where we're going with this is that going wrong is one thing, identifying where they went wrong is the second thing. And the more important thing is that assuming you've got the information as to where you've gone wrong, it's all about trying to improve your performance from there without any human re-engineering or interaction. That's where we are kind of looking at self-improving agent. Now, certain key characteristics from a self-improving agent standpoint, we've seen, they are continuous learning by nature. So they improve with the new data or experience. Every time there is new data, which is for them. Now, they may either go in terms of, some bit of change policy management, or they could also basically use that new data to kind of fine tune the model better to kind of get a better response. Or it could be just plain simple exception handling, which needs to be done a little differently in order situations to go south. Now, the next part, where from a characteristic standpoint, we've seen adaptive architecture. This is the fairly important area, the whole part of the agents is that they've been designed to address a specific workflow, and with workflow comes a certain set of internal structures and strategies, or I would say certain degrees in terms of behaviors, which how the agent must react. Now, as we kind of come across the adaptive side of it, there are chances where the initial strategies may not quite be in line, or the agents agents in conversations are at a point where they need to evolve, and that is where the adaptive architecture really comes into picture, which allows the agents to automatically improve themselves, improve the workflows and strategies and later structure the thing. The feedback loops, they're the very basic stuff, which is the basic construct which is required to evaluate, revise, and improve. So this is something which I guess we pretty much. I said the last piece is more forward-looking. It's meta learning. Now, meta learning is a piece, where the model learns to learn. Now, I know it may sound a mouthful, but the idea, the meta, is basically, the models have been trained to do a certain set of tasks. The model can actually learn to do again certain set of tasks in a different domain. So basically, we are adapting our a finance trained model for other domains. So that's how it basically, because the learning principle remains the same across the board, and that's how the meta learning comes into picture. Now, why it matters? Most agents are static. They execute predefined logic, and self-improving agents, in contrast, have to adapt, evolve, make them ideal. Now, dynamic enterprises environment for operation compliance and workflow. I mean, most of the software that we kind of built in the last 30 years, uh, you know, they have some degree of dynamicity in that, but then again, that's a conversation for another day. Now, going further in terms of what are the paradigms that we see from a self-improving agent standpoint of view, the self-play, very simplistic one where you actually have a proposer, solver, and a judge. So before that, you actually have a critique model, which is a judge model, which is trying to basically evaluate if the response is coming out of the it needs an improvisation, and then you can actually throw in a reinforcement learning loop. Now, a proposer solved by recharge is just a set of three agents working together on the same line, which is using a lot of the LLM intelligence to kind of do the improvisation. But that's the very basic, available set in terms of self-improving agents. Now, RL is more from a reward engineering standpoint, where that kind of basically takes the model's output, evaluates it, assigns the reward to it, and there's a critique model which kind of comes into play, and then eventually kind of getting to a point where there is a degree of improvement, and for every wrong answer, the model is supposed to get penalized, and likewise, the model also gets a reward in case the answer is right. Now, there is there's some degree of fine tuning which comes into play, but I won't talk about the fine tuning right now. Now, now getting into the next space, which we call it partially observable Markov decision process and POMDP based model. Now, this is a very different segment. If you really kind of go down to any decision making process, specifically where we use Markov decision making process, it's essentially but sequence of states in action. For every new action, there's an equivalent and opposite next state, which the model is likely the output is supposed to reach. And based on that, that's where the MDP really comes into play. And I will be talking a little bit more on the PO MDP front a little later in the slide. But PO is more the partially observable piece where you only have some parts of the data and you are supposed to do a lot of guesswork to kind of understand what the remaining part is. That's an interesting piece. The next is meta learning, which I just talked, and the last is tool augmented external feedback. So we are actually going from a very synthetic imitation to a slightly more cognitive reasoning. Now, let's get into the Markov decision process and the POMDP side of things. So basically, from decision to learning. Now, like I talked about, the Markov decision process is about a set of states and set of actions, and there's a transition probability, how the world evolves, and there's a reward function feedback, for this environment. Y is a discount factor of the future rewards. So basically, from going from state HT, you basically take an action AT, you eventually go to HT plus one, and there's a reward RT associated with that. Now, at each timestamp, the agent observes the current state HT and chooses the action AT and receives the reward RT and moves it to the next state. Now, learns from a policy and that maximize the expected cumulative input. Now, this is where the whole DPO and GRPO based policies kind of come into play. But I'm not going to talk more into that, but just trying to stick into the topic of the Markov decision process. Now, you could, at a bare bone, end up using MDP for some degree of self improvement, because since you have the set of states and actions, and you have the entire trajectory and you have the associated probability for every transition from state one to state two. So then it becomes a lot easier in terms of basically trying to predict what the next state is going to be. So that's one way of looking. But having said, the real world, in case of the model scenario, we really don't kind of get to see the full blow up of the states, and it's partially observed on nature. So I mean, that's where the real world kind of sits. It is a degree of ambiguity. And with that degree of ambiguity, actually means that, you have to make sense in terms of what this thing, and that's where the belief comes in. So, like we humans, we believe that, there is going to be a better tomorrow. So, having said that, now, going on specifically on that belief, now, when it comes to real agents, human and machine rarely get to see the full. And that is where we need to infer what's going based from limited signals. And that's exactly what we're talking in terms of gut. So POMVP is basically, it's the same thing as MDP, but you just have an additional layer. The agent doesn't observe the true state ST. Instead, it receives an observation O, and it must infer a belief BT. And the BT is basically a probability distribution over the possible state. So this is where we kind of coming where, for every state change to the next state, we actually kind of come up with possible probability distribution. That is a trajectory, that is a set of answers in case of the model. So basically, let's say if you're looking at an agent and that's supposed to basically take in the new customer request for account opening, what could be the possible next states in situations like that? There could be a bunch of next states in terms of, and trajectories. Choose the right one and move ahead. Now, POMDP is NDP in general, the agent learns not just what to do, but what it knows and it doesn't know. Further, how does this improve, fit into the self-improvement side of things? Now, if we're actually kind of getting into the whole self-improvement game, system has to learn over a period of time in terms of what are the possible states, and some of it's going to be partially observable. There's a policy associated in terms of how the corresponding, guideline in terms of how, what decisions to be taken. A self-improvement agent isn't about answering correctly. It's more about thinking better over time, and POMDP gives a machinery to describe. So it kind of gives you a very formal framework to kind of get, and that's exactly we're hoping to use in our self-improvement paradigm, rather than rely on simple LLMs to kind of that. Rather, you put a construct in between where you have a set of policies and you have a set of states, and you kind of work through the whole framework in terms of identify the next potential answers, and you have a probability distribution, and based on that, you kind of take the right answer. And there's a certain belief around the entire thing. So basically, coming down to the POMDP element, we have the belief state, the agent's understanding of the world and itself, what it currently knows. There's observationality, feedback, outcomes, critiques, or rewards in the environment. There's an action, AT, the agent's next experiment behavior hypothesis. The reward, evaluation of the decision of an answer quality. There's a transition function which basically then there's a policy. The policy is nothing but which governs in terms of what the agent is supposed to do. Now, having said that, I want to just kind of give my side of the story in terms of why I wouldn't go with the solver judge model. The solver judge model is great, but it's kind of stuck to the blame from LLM reasoning. It's not grounded probabilistic feedback. So where we go in the learning source case of propose a solve while judge model, we're actually kind of getting to a synthetic linguistic feedback, as opposed to what PMDP really has to offer as a grounded probabilistic feedback. Now, temporal continuity is not there. It's since we have a certain degree of, belief states and the transitions and the states associated with that, we exactly know we are temporal by nature. So we exactly know where we came from, how the decision actually came to at this point, and why did we take that decision. So it gives a certain degree of explainability also. The ability to handle uncertainty in case of pure LLM play or PSJ play is ignored. And this, in case of POMDP, is explicitly modeled because POMDP, the framework sits on the principle of uncertainty and ambiguity. And that's exactly where we go and we talk about partially observable. Memory, yes, it's prompt limited. In this case, we have a belief state buffer before, after practically everything there is to do with the decision-making process. The goal is to win the debate. Here is to reduce uncertainty and maximize reward. So we're working for it different. And the cognition type is reflective in imitation. Here is recursive reasoning and planning. So you can actually judge for yourself as to which one is really, really, really getting into the space for real reasoning versus just role play. So having said that, the key line is the PhD is three people arguing about both. POMDP is a one-mind learning the structure. But having said that, it kind of gives us, this is the overall, just a high-level diagram which we've implemented for the POMDP as our improvement framework for most of the audits. But anyway, I'm not going to go. I'm going to leave the link of the GitHub for you guys to kind of go through later. I want to take a minute and talk about meta learning. Meta learning is an important aspect which is more forward-looking by nature. It's not something which is going to come immediately. So the agent tracks its own learning performance, so treating learning parameters like learning rate, architecture, prompting style as a variable to optimize. And now this is the space where we actually kind of get into, if you kind of recall the days when you actually learned regression, you were trying to solve the problem in minimization. And that is where I use gradient descent. Now, similarly, out here, since this is a learning rate, there's a set of variables which we want to optimize, and the idea is to basically have gradient-based better learning and effective prompting more to catch its resistance and continuum learning. Now, this is an area which is to be watched out. It's not something which is immediately available. And it is something which will come in due course of time, but it is an area which I'm going to be experimenting a lot more to kind of understand this better. But as of now, I have a very high level understanding of it, and it definitely is a construct which should be there for most of the self-improvement based models. And that's it from me. On any comments and suggestion, please reach out to save that innovation hashtag AI. Thank you.